First of all, I like to thank for giving these opportunities. See, my topic is a replacement of single-use plastic by paper products. This in packaging. Normally, packaging is a wrapping of an object to make them use to avoid damages during storage and transportation. But based on that applications, it is classified under three categories. One is primary packaging and secondary packaging and tertiary. The primary packaging is directly related to food products. That is, the packaging is direct with food. The secondary is a box packaging. Packaging is grouped by primary packaging material, and the tertiary is bulk packaging, or it is used being for transport purpose. Here, directly I will go for food packaging. What we need in food packaging with respect to safety. Here, no hazardous components should react with food within the packaging, and food must not change the originality with respect to appearance, taste, odor, and smell. Another one is it should not absorb oxygen or gas barrier, and it should not create any microorganism development, and must follow the FDA regulations. Then now the following material is available for packaging. In general, all the three categories, starting from metals, glass, aluminium, and paper, apart from plastics. If we say glass is the best material for food packaging with respect to barrier properties, but because of this breathability and transportation, it occupies only limitation some percentage, but it is a good material is being used. Next comes as a metals. Metal packaging also is good, but with respect to food packaging, while filling the this one food, it needs some coating materials. Inside there will be a layer to protect food material, so like Pepsi bottles, Pepsi tins and all. Next comes to paper products. We know the paper is we need not explain more about the paper, recyclable, eco-friendly, and it is having a negative with respect to barrier properties, because it cannot, because of porosity, it is not having any barrier properties with respect to water or gas. But still, we are already, there are so much paper products available in the market, but it is everything in short life. But in case of plastics, these are the plastics is being used for food packaging. Why? Actually, this proportion in the market is heavy because of its some advantages. We should not underestimate plastic. Plastic characteristics, because of its durability, strength, easy design properties, and lightweight, apart from the price. Because of that, everyone has gone to this plastic packaging. This development is only last 2 decades, but at the same time, when using this plastic packaging, there are two categories. Only single-use plastic. When going more than 50 microns, it is going for mostly industrial purpose, and less than 50 microns is going for food bakery. There, that single-use plastic comes under food bakery. Really speaking, even less than 50 microns, this is not. It is having only poor barrier properties. With additional single layer or 2 layers, they are making pouches and other things, and they are going 2-3 coatings. That is with plastic. Finally, it is going in landfill. This is the issue. Now we understood that this creates environmental and human problems. That is why government has listed and banned these plastics. Now at least government has understood. He has banned this. This material has to be avoided. At what cost? What usage? That all the publics, all the consumers have started using plastic, but overnight it cannot be changed. But we should give an alternative. Then only consumers will go for alternatives. Otherwise, they will going on using. This is the normal our paper products. This is all short life already been doing that plastic world. This also already developed, it is in the market. See, craft paper for secondary packaging and glass and paper, grease proof paper, bleached paper and vegetable format, that whiteboard, these are tableware, that modern product. Now there is so much development in modern products to replace it. Yes, it may go up some this percentage of this paper product, but what about that replacement of plastic? Replacement of plastic is entirely different from these plastics. We need to, since we have negative factors in paper, we need to modify surface modification of paper, then only it can be treated as a plastic film. From during that film we got to use for food packaging. This is all the barrier coating, flexible packaging. This that coating we know there is water based coating, solvent based, wax based, extrusion based. These are all applications. Liquid packaging and bakery, mainly bakery. Here now we have to come for barrier coating. What is barrier coating? Is a coating of one non-porous layer in the substrate to protect surrounding environmental impact with respect to barrier or with respect to gas or oil conditions and moisture vapor. Here paper, if you want, this is a paper packaging board waterproof party already in the market. These are all the normal products. This is not related to food packaging really. Then we have to concentrate for biopolymers. What is the difference between the biopolymers and that is, I can say bioplastic and normal plastic? Bioplastic is made from the sugars converting into plastics. That sugars has to be extracted from biomass, so it becomes bioplastic. These are three types of bioplastics: only starch based, cellulose based and protein, then lipids. Apart from that, biosynthesis, that we have to extract biomass and we have to make a biosynthesis, that is called bioplastic. This is directly natural bioplastic, this synthesized bioplastics. So bioplastics, there are three types. One is polyesters, polylactic acid and agro-based. Fortunately, polylactic acid, which comes out from corn with fermentation process, now it becomes popular and everybody started using this in place of polyethylene coating. See, normally in the polyethylene coating, this cups, that tea cups, we are making around 10 grams with 100% pure biodegradative properties and heat sealability and everything. For replacing that, they have developed this bioplastic. Here I want to talk about more about polylactic acid. It is a synthetic and bioplastic polymers. It is usable really. It is a biodegradable and eco-friendly. It is having low energy consumption during production, and PLA is amorphous in nature. Here one disadvantage is PLA they are giving an amorphous in nature with slightly lower molecular weight, and they are doing extrusion coating like PE. PE extrusion coating is different, and here the same format they are doing. Since that amorphous nature is a low molecular weight, it is having poor permeability property, that is barrier properties, and poor glass transition temperature. Definitely it is slightly inferior than the PE coating. So it is not, we have tested several cups made out of PVA, but it is not fulfilled. Now some problems is there with PVA, so we have to concentrate that particularly that polymer peoples has to modify to dispersion level. Once if you do dispersion, it is easier for conversion people. While doing conversion with dispersed form by emulsion polymerization, we can alter the barrier properties by introducing the some other chemicals like our water soluble polymers. So, the conversion of that conversion has to be done during polymerization itself, not in conversion stage. Once if it comes as a solids like extrusion stage, we cannot change any properties during application. But if it comes in polymerization as an immersion polymerization, we can modify the barrier properties, we can modify the heat suitability, and we can match the property even much better than the PE. This is the bioplastic. Like this, that other bioplastic also is there. This is a polyglycolic acid. Polyglycolic acid also the same method is generated from bacterial growth, bacterial root and biomass. Then polyhydroxyalkanes, this also is the same. All these things under research, but PLA has come to market. This is under, but it is slightly better than the PLA with respect to strength and other properties, but since it is costly, it is under research area only. Then this is PPS, this is an aliphatic polyester, again the same group. So, bioplastic is the only solution for replacement of PE, particularly teacup area. But at the same time, we are talking about only for teacup, but this cannot be used for food packaging really. Food packaging has to be full packed food. If it has to be contact with the food, and it has to be shelf life maybe even 1 month, 1.5 months like that. For that, we need emulsion coating with all the other properties. All these bioplastic has to be converted to the to be manufactured through separate advantages or separate this kind of process conditions. See, polymerization is not easy. Each and every monomer will behave differently. Instead of while doing polymerization at 45 degree, that you will give separate properties. The same monomer, if you do 50, that is different. Apart from that, if you introduce one monomer in that during polymerization, that behavior it goes externally. So, optimization is from monomers, materials used, and process condition is very, very important during polymerization. That polymerization people are very, I have to thank them. Their development is very high level. You know that PE already coated, PE coating till now we are doing extrusion coating only. But Dow Chemicals has done that PE coating itself in emulsion polymerization. While any polymer comes in emulsion form, it is easier for conversion. That consistent properties we will achieve. That consumer will be happy. So they have, while doing emulsion polymerization in PE itself, why can't we do with bioplastics? So if you develop emulsion polymerization with bioplastics, we can solve almost 90% of our food packaging problem, because we can introduce barrier properties, whichever heat solubility, everything we can do. Only the controlling the molecular weight range is important. That is only technology. That it is under their control, and already I am sure that it is possible in future, near future it will come, it will help us like anything. In CSSI papers, we are also making base paper. As yesterday Dr. Sir said, we have to make very good paper, which is, because ours is substrate, almost 90%, 98% of 98% of material will be our paper. Only 2% will be their polymer, and almost 25% is the conversion process. In that, so each and everyone has to concentrate in their area. So we have to make our paper. We are making around 2,000 tons, which is going for cup stock and paper bag and paper plate manufacturing. For that, we are changing our paper pulp furnish. We are using softwood. We are supplying with high strength and flat paper with higher GSM, even single layer and multi layer. See, if we do any properties, That depends upon the end users. So while coming to paperback, we need higher strength. If any paper goes to coating, definitely we should give higher strength paper. Based on that, we have to make. Apart from that, it should not contain any adverse effect on this chemical content. So virgin paper will be possible for particularly for food grade. So yes, we have taken some trial with water soluble polymers for OGR coating. We have, with the help of other one coater, there two coater air knife and blade coater, we have applied the same two-stage coating. While doing two-stage coating, we got a very good kit value with 8 grams. The same combined in same gram with single stage, it is kit value is 8 and double coating it is 12. That means the process also important. If you do any coating, if you do double coating, it will fulfill the properties will be regularized. Any problems in the first stage, it will be rectified in the second stage. Any some fin holes, anything comes, it will be filled up in the second stage. So the process is important. At the same time, if we apply more polymer, it will also gives problem. So one trial gives blocking. That means we have applied more. But yesterday also I have seen that some polymers that starch based and all results goes to 15 grams, 10 grams, 15 grams coating, 20 grams coating. If you start with more than 10 grams, it is not viable. Cost wise, we cannot match. Apart from that, we cannot make uniform quality. We expect that barrier properties and heat sealability should come within 5 grams, 5 or 6 grams. Then only it may be cost effective. For example, for PLA, if we compare the cost of PE and PLA, it is 3 times. Apart from that, it is only 80% of properties are matching. Cost wise, it is going up. We will bear it. Even for example, if you want a gold, it can be made with SS, MS, gold or even platinum. But people can offer instead of MS in SS price, not with gold price or platinum price. So we have to develop our polymers, our product with affordable cost. People are ready to give higher cost, but we have to give proper quality for at that cost. That is important. So as a conclusion, now one more example I want to tell. See, last even 1950, last 50 years, we are using that PFAS polychloro coatings for food packaging. One side we are talking about we are spoiled by using polyethylene by environment. We are using for food product. How much human beings would have affected? Suddenly we found out that these are giving human it is against human health and conditions. Now it is banned in all the countries, starting from France is the first country to stop that. Now UK and US and everybody has stopped. So we have to, now we are not having a standard testing or standard what will be the impact that yes, every countries, as yesterday as Sir also told, foreign countries the system is very good, but Indians also it is coming, but it is not implemented. But we request CFTRI to make clear-cut testing, and they should help us by testing. When any product comes into the market, it has to be certified by them, so that it should not affect human being. After making 10 years usage, one big report comes with this is not human, this is not health, this affecting health means everyone will get fear. So while making a polymer, the polymer people should clearly knows that each and every monomer polymer, we can say some 1 or 2 monomers here, they are doing some 3 or 4 materials for addition of each and every properties. So the selection of material is important, process is important. So we have to work in collaboration with as paper makers, converters, chemical suppliers, technology providers, and research. All these, everyone they have to contribute in their area. That is important. As a team, if we work, definitely this task maybe looks big, but it is not big. It can be changed shortly. Yesterday, one discussion has come, only 10% is plastic, why don't you change paper? Yes, these properties are matches. 10% is not a big problem for paper makers. Only 10% we can adjust to furnish and we can give high strength paper which is useful, which can be matched with coating process. Now also people are supplying good high strength paper for coating, only small consumption is going, but we can develop. So I request all of our, since we are in team, everybody should understand our responsibility and we have to work. If we work together as a team, we will succeed. We will definitely eliminate plastic shortly. At least not 50%, at least 80% can be removed. Thank you.